with your flip book on the properties of powers. So today what we're focusing on are the two flaps on the bottom right of your booklet, the negative exponents and the zero exponents. So you should have filled in, these other flaps in class. If for some reason you don't have it, you are welcome to look on with somebody and get those filled in today. But our focus right now is going to be on negative exponents. So I'm opening this flap and I'm going to be writing right here on the back side of the flap. I'm actually kind of starting towards the middle here. So let's suppose I give you x squared over x to the fifth. And I want you to look at what happens with something like that. Following our rule for division, back when we talked about division, we said that when you divide powers, you really subtract the exponents. So that would mean this value, 2 minus 5 is negative 3. This is actually equal to x to the negative 3 power. Okay, so this is where the negative exponents come in, is when you have more on the bottom than you do on the top. Well, let's write this out like we did before. X squared is like x times x. X to the fifth is like 5 x's in a row, all multiplication. And then when you cancel them out, what you're left with is x to the third power. But notice this time it's on the bottom of the fraction instead of on the top. Whereas when we did division, it was on the top of the fraction that the numbers were left over. So what you really have here, what this really comes out to be equal to, is 1 over x to the third power. Okay, because x to the third is on the bottom. If it's on the bottom of a fraction, we need to put a 1 up on top to be sort of a placeholder, because you can't have a bottom unless there's something on the top. Okay, so we need something on the top. So look at what we started with and look at where we ended up. Okay, we had x to the negative third, and when we were done, it ended up looking like this, 1 over x to the third. That's like taking that and flipping it over. This right now I could write as x to the negative third over 1. And then to get my answer, what I did was I flipped these two things. Okay, hopefully that looks familiar to you. That is called taking the reciprocal. So when an exponent is negative, we take the reciprocal. Okay, so when an exponent is negative, we're really taking the reciprocal of that power. Okay, so you're going to switch what position it is in the fraction. Okay, so let's go over here and do a couple of examples. First example, 4 to the negative third power. Second example, 2x to the negative 2 over y to the fifth. And last example, 4b to the third, c to the negative fourth, all raised to the power of negative 2. Okay, so 4 to the negative third power. The biggest thing I want you to get about negative exponents, you're going to hear me say this a lot in the next few days, but the biggest thing I want you to take away is negative exponents do not make your answer negative. This does not mean do 4 to the third power and then just make your answer negative. It also does not mean 4 times negative 3. What it means is to do 4 times 4 times 4, but put that underneath a 1. This negative is telling you to put this on the bottom of a fraction instead of on the top. Okay? So 4 times 4 times 4, that's 16 times 4 is 64. So your answer here is 1 over 64. Okay? Notice nothing in your answer is negative. The negative is just there to tell you to put your answer on the bottom of a fraction. Okay, so look at the second one. And in situations like this, you're going to hear me use this phrase a lot. Which one of these things is unhappy? Okay, you've got a 2, you've got an x to the negative 2, and you've got a y to the 5th. The 2 is happy where it's at. The y to the 5th is happy where it's at. But this x to the negative 2, this negative, means that this x is not happy where it's at. Okay, this x wants to switch. It wants to move downstairs. Okay, not happy with the upstairs apartment. Everything else is staying put because everything else is positive. Everything else has a positive exponent. So the 2 is going to stay put. The y to the 5th is going to stay put. And all that's going to happen is this x is going to move downstairs with the y. And now that it's moved, it's happy, so that exponent of 2 is going to become positive. Okay? I guess I can move this 2 over a little bit, put it right in the center, and that's what your answer would look like. Okay? So the only thing that moved is the x to the negative 2. That moved downstairs. Everything else stayed right where it's at. Okay, the last one. When I do 4 to the power of negative 2, remember that's really telling me to do 4 to the power of 2 and put it on the bottom. Okay, this negative sign is telling me put it on the bottom. So 4 to the power of 2 is 16. 4 times 4 is 16. A lot of people are going to put negative 8. That is wrong. 4 times 4 is what this is telling you to do. Put it on the bottom. That's going to be 16. Now here, I'm just going to follow my normal rules. So I'm raising a power to a power. From way back at the beginning of our flip book, when we raise a power to a power, we multiply. So if I do 3 times negative 2, I get negative 6. Okay, so negative 6 means that that needs to go on the bottom. If it's negative, it needs to go on the bottom. So I'm going to put b to the 6th downstairs. And notice once I put it downstairs, it's not negative anymore. Okay? It was negative when I multiplied it, but then I put it on the bottom, and now it's happy. That's where it wanted to be. Okay, so once you put it where it needs to go, you don't leave it negative anymore. But watch what's going to happen here. Negative 4 times negative 2 makes a positive 8. Positive means it's going to stay up on the top. So c to the 8th is going to end up there. So with these ones, you kind of have to work your way through and just decide bottom or top as you're working your way through. One thing that's not reflected in these examples is what happens if you have a negative that's on the bottom. Like if this were b to the negative 6 on the bottom of a fraction. Well, that still means it's unhappy, and that would need to move up to the top. Okay? So negative exponents means switch which place it's in the fraction. Okay? Either move it to the top or move it to the bottom. And then once you do that, it's not negative anymore. Notice none of my answers have negative exponents in them. Okay, let's move on to 0, because 0 is actually a whole lot easier. Okay? For 0 exponent, we're going to do something similar to what you did a minute ago. Starting sort of in the middle of your flap, I want you to write x to the 3rd over x to the 3rd. Well, again, using our division rule, we know we should subtract these, and 3 minus 3 is 0. So what I really have here is x to the power of 0. But I also know something else about fractions. Okay? In a fraction, if you have the same thing on the top and the bottom, think like 5 over 5 or 2 over 2, that's always going to be equal to 1. Okay? So writing this out this way, if I follow my division rule, I get x to the 0. If I follow what I know about fractions, I get an answer of 1. That means x to the 0 always equal to 1. Okay? So your rule for zeros is really simple. Anything to the power of 0 is equal to 1. I'll kind of cram that together. That is equal to 1. Just 1. Not x to the 1, just 1. Okay? So, for some examples, let's do 4 to the power of 0. Let's do 5 times 3 to the power of 0. Let's do 12x squared over 4y to the 4th to the power of 0. And we're going to do 4 of them here. Let's do 10x squared y to the 0. Okay, take a second, get those written down. All right, this should be super easy. 4 to the power of 0 just equals 1. Anything to the power of 0 equals 1. I could do 1 million to the power of 0, and the answer would be 1. Anything to the power of 0 is 1. Now pay attention, though, to where the 0 is, because, for example, on this one, this is the only thing being raised to the power of 0. So what you really have here is 5 times 1, which is just 5. Okay? That next one looks really scary. Is there some stuff we could do inside here to simplify? Sure, but let's not waste our time, because this whole thing is being raised to the power of 0, which means this whole thing is just equal to 1. And then number 4 is sort of similar to number 2. Y is being raised to the power of 0. So really this says 10x squared times 1. But think about that. 10x squared times 1, you don't even really need the 1. And so that's why people think of this as canceling out. It's really turning into a 1, but a lot of the times in multiplication problems you don't need a 1, okay? Because multiplying by 1 just keeps everything the same. So that's why you can kind of think of this as canceling out. Just remember that if the whole thing cancels out, you still have a 1 left over. Okay, so anything to the power of 0 equal to 1. Okay, please use what is in your flip book to complete your homework assignment for tonight, which was 2 pages. One of them said powers of monomials and then multiplying monomials on the back. And then the other one said dividing monomials and practice 8-1 on the back. And remember, for all of them, even if they are matching, you must have the answer to the question written next to the question. You can't just have the letters, okay? You've got to have the actual answer written next to the question so that when you look back at it later, you can see what the answer is. You will not get credit if you don't write the answers in, okay? All right, have a great day. Please let me know if you have questions on any of this.